Okay, hello everyone, welcome back. So in today's class, we plan to talk about the deep learning model optimization for you. So as we know before, for the machine learning models, when we are training them, actually the process involves the optimization process of some loss functions, right? So we can learn the optimal variables or parameters for the model, which we define the model to be trained, right? We plan to provide you with a brief introduction to the deep learning optimization algorithms we can use for training the models. So this optimization in this area is very big, and what we can do is just provide you with some necessary background knowledge to help you understand the training process involved in training the models in PyTorch, right? So here's the outline for today's lecture. In the very beginning, we will be talking about the deep learning model training key factors. Because the training process is very complicated, it involves or depends on many factors about both the model, the problem, as well as the data we are studying. And all the model and the optimization algorithm will also involve some hardware parameters as well as setups, which will be necessary to ensure the training process will be very smooth and successful. And then we can provide you with a very toy example about the quadratic function optimization. How can we optimize them? And then we can further introduce the gradient descent algorithm, which will be the key algorithm to be used for training the deep learning models, because this gradient descent algorithm is much more efficient than many other non-gradient based algorithms or high degree gradient based algorithms. And for the gradient descent, this algorithm will have different variants as well, and we will be talking about them in this lecture as well. So the first one we'll be talking about is called Memento. Memento is also based on the gradient descent. However, we further consider some other factors in calculating both the gradient as well as updating the variables. The second one we can use is called adaptive gradient. It will further consider different learning rates for different variables. And then we will talk about the Adam. Adam is more like a combination of both Memento as well as adaptive gradient. So the Adam incorporates the advantages from both of these two algorithms together, and it will be much more effective and efficient for many of the cases. And finally, we will talk about the prediction results as well as the loss function that we can use for training the deep learning models for you. And then you should be able to train a deep learning model based on knowledge we learned from this lecture by yourself. Okay, so about the deep learning model optimization key factors. Actually, the deep learning model training depends on many factors. So for example, it depends on your data as well as on your task. So for different kinds of deep learning problems, we have to rely on different kinds of data, right? And for different data, we have to design the model in different ways, and we have to design different model architectures. Furthermore, also depending on the size or the volume of the data, we have to consider the constraint by our machine. Sometimes we cannot involve all the data into the training process, right? We have to divide them into small subsets or small batches, as shown here. So depending on the size as well as on the category of the inputs, we have to decide the training strategy very carefully. For example, we can either use a full batch, or we can use the instance for training, or we can use intermediate size called mini batch of this input data for training instead. Also, it depends on our outputs, because for different outputs, we have to design the loss function in different ways, right? And for different loss functions and also different outputs, we have to design the training process in different ways as well. So the learning process depends on our data, our task, our inputs, and our outputs. Also, the training process also depends on the model architecture, because for different model architectures, we have to design different training strategies for our optimization process of the model. And also, for different model architecture, we incorporate different variables to be learned. Some can be more complicated, some can be much more easy, right? So it really depends on the model architecture. Also, for the variables to be optimized in our problems, and we need to decide how do we do the initialization of these variables, because later on we will show you when we are doing the training, actually we are doing the searching process via the gradient, right? So we have to do the searching starting from some points, and these points are called the initialization of the model variables. We have to initialize the variables first with some initial values, then we can start from them to do the searching process based on their gradients. And there are different model variable initialization methods, and we have to decide them as well when we are training the models. Also, the model architecture will incorporate different kinds of hyperparameters. Normally, these hyperparameters cannot be learned by the model, and we have to assign the hyperparameters about ourselves manually. And we have some search methods like a beam search, which also depends on the manual assignments. So, this model architecture also decides the hyperparameters to be searched by us for deciding the final model architecture. And then it also depends on the optimizer or the optimization algorithm to be used, which can incorporate the learning process or the updating process in the optimizer. Also, this optimizer may involve some hyperparameters to be decided by us, and these hyperparameters can affect the performance of these optimizers greatly. We have to decide these hyperparameters very carefully. In this lecture, we will talk about some of these optimization algorithms or the optimizers for you, like SGD, as well as Momento, as well as adaptive gradient and Adam, and some others. And we also introduce some of the hyperparameters will be involved in these optimizers, like the learning rate, as well as the weights for some other terms involved in the updating process for the optimizers. Of course, the training process also depends on the specific algorithm for the deep learning training. We can either train purely based on the gradient descent. We can calculate the gradient of the loss function regarding each of the parameters. However, it will be less effective and efficient for very complicated models involving millions or even billions of parameters. And we may wonder if we can utilize some of the intermediate results in the calculation process for the lower layer optimization. And then we will introduce a very important algorithm, maybe in the next lecture. It's called the arrow backpropagation algorithm. This algorithm is also based on the gradient descent. However, this arrow backpropagation allows us to utilize some of the intermediate results we calculate for the higher layers to be used for the lower layers. It will be much more time efficient and as well as more effective for training more complicated deep learning models. So, in this page, we try to provide you with some of the key factors which may affect the training process of deep learning models, and we have to consider them very carefully when we decide in our training process as well as training algorithm.